Hi, I'm John Paul Raj, and I'm on a mission to make the learning of math fun. So, if you're new to this channel, please do consider subscribing. On this video, we're going to talk about how to solve a quadratic equation by completing the square. So, let's start. We already saw in part 11 of quadratic equations that this form is called the vertex form. The vertex form. So if you haven't seen part 11 of the video on quadratic equations, I'm going to link the entire playlist there so you can go and take a look at it. The general form, this is the general form of the quadratic equation, how to write the general form in the vertex form. And we need to write it in the vertex form in order to be able to solve it. The process, the algebra of writing from the general form to the vertex form is called completing the square. So this particular video, we are going to focus on the algebra. In that particular video, part 11, I have just shown you how to write the vertex form in less than a minute. Okay, so if there's a place and time for such kind of problem solving, especially when it's a multiple choice test and you don't have to show the working, the algebraic reasoning. But in this particular video, we're going to focus on the algebraic work. That means how we can use algebra to transform or to rewrite a quadratic if it's given in this form meaning this is the general form. And from the general form or the standard form, what is the algebra that brings from the general form to the vertex form? Ready? Let's go. So if your quadratic equation is x squared plus 4x minus 11, we already know what that a, b, and c are, right? So I'm just going to write it down here somewhere in the rough, okay? So this is the rough work. Can you see that? All right, so a is 1, b is 4, and c is my 11. The first thing to do, apart from writing that in the rough, the first thing to do is that the c term, that's why I wrote it in the rough so that you know what I'm referring to. The c term, the constant term, take it on the right hand side, okay? Basically what you're doing is that you're adding that term, adding 11. In this case, it was minus 11, so it makes sense when I say adding 11. So basically, it's not that the term jumps to the right hand side. It's just that you're adding 11 on both sides. So let me explain what I mean by that. So whenever we have x squared plus 4x minus 11, basically what you're doing is that you're adding 11 on one side, and so also you got to add 11 on both sides. That maintains the equality. Sometimes I think you read that 11 goes on that side. That's not a correct way to say that 11 goes on that side. Basically what's happened is that you've added an 11 on both sides of the equation. If it was a plus 11 there instead of the minus 11, you'd subtract that 11 on both sides. Okay, that is correct mathematical language. And that is what's happening when you are actually saying things like something goes on the other side. It doesn't go. You're basically adding or subtracting a term on either side. So on simplification, what then happens is you get x squared plus 4x, that negative 11 plus 11 makes it a 0, and therefore it looks like that 11 has actually gone there. It's not gone there. Just as I've clarified, you basically added 11 on both sides. Now, that being said, the constant term should be on the right hand side. So on the left hand side, you'll just have a and b, just the a and b on this side, okay? Now, after having done that, what we need to do on our rough work is, let me make sure that I have enough space for the rough work and that you can see that, we identify our b, all right? So we've already identified the b as 4. We find out b by 2. You have to half it, okay? B by 2, in this case, b is 4, so it's going to be 2, all right? Then we square that term, b over 2, we square that term, and here we get 4. This was nice number. Sometimes you get numbers that are not so friendly. It will be a fraction. Just leave it as a fraction. Don't go ahead and make it a decimal, okay? So leave it as a fraction. It was something like 1 over 7. The square of 1 over 7 would be 1 over 49. Just leave it like that. Just follow these stages and you'll be fine. This particular term that you've got now, you add that on both sides. So I'm going to write it down here, okay, in words. Add b by 2 the whole square on both sides. So what will happen as a result of that, you would get x squared plus 4x plus 4, and on the other side you have 11 plus 4. Can you see this? All right, here we go. Okay, so then that would simplify as x squared plus 4x plus a 4 is equal to 15. Now we need to recognize this as a perfect square. We call it a perfect square. We call it a completed square form. Basically what happens is that this formula a plus b the whole square is a square plus 2ab plus a b square. Can you see this formula that I've written? Or you have a minus b the whole square is a square minus 2ab plus b square. One of these two formulas will be used, okay, to recognize or to identify what those terms on the left hand side will combine to or will reduce to. Okay, so in a compact form, x square plus 4x plus 4 can be written as x plus 2 the whole square. All right, so that can also be identified as saying this was my term. This is the term that we're looking for, because b by 2. The b by term is what we've written here. Whereas on the right hand side, we can just leave it as 15. Okay, now when you've got it at x plus 2 the whole square is equal to 15, you can take square root on both sides. That would give us x plus 2 should be equal to plus or minus under root of 15. Cool. And then we just write in terms of x, that will be x is equal to a negative 2 plus or minus under root of 15. So that is the process. That's the value of x. You've got two values of x, negative 2 plus square root of 15 and negative 2 minus square root of 15. Let's go with the process again. Okay, so this is the algebra. So you have x squared plus 4x minus 11 is equal to 0 as given in the question. The first thing to do is that write on the left-hand side just the a and the b terms. So once you've identified a, b, and c, the left-hand side should only contain a and b, which means the c term should be, whether you're adding or subtracting or whether you're using your language, it goes on the right-hand side. Okay, just make sure that the c is not there on the left-hand side. Okay, after you've done that, you got to add b by 2 the whole square. So whatever your b is, whatever you identified b as, first find out b by 2. Okay, so you half it. Okay, and be careful, even if it's a fraction, leave it as a fraction. B over 2 the whole square, that's 4. That is what you're going to add on both sides. Okay, that's what we've added on both sides, and that reduces to x plus 2 the whole square based on one of these two formulas. Okay, so if it were a negative sign, it would be negative. If it were a positive sign, it would be positive. So x plus 2 the whole square giving you 15, and then it's just a matter of taking the square root on both sides and then solving for x, and that should give you the two values of x, which are the two roots of that quadratic equation. All right, example 2. 4x squared plus 2x minus 5 is equal to 0. This is a case where a, the leading coefficient, the coefficient of x squared, is not equal to 1. In this case, the first thing to do after you have brought the c term to the right hand side, okay, I mean, I'm reluctant to use the word bringing it to the right hand side because, as I said, the actual thing is you're adding plus 5 to both sides. Okay, so first thing, do that instead of identifying a, b, and c. Okay, the first thing I said here, when the leading coefficient, the value of a was 1, I said first identify a, b, and c, and as you can see, I'm not doing that. The first thing I'm doing is that I'm bringing the c on the right hand side. Okay, I'm still using that word bringing the c, but basically you understand what I mean. You're adding 5 to both sides. So this equation actually becomes 4x squared plus 2x minus 5 plus 5. You're adding 5 on both sides is equal to 0 plus 5. This should give us 4x squared plus 2x minus 5 plus 5 is a 0. So on the right hand side, you've got 5. So the first thing to do whenever the coefficient of x squared is not equal to 1 is first isolate that c term, the constant term, keep it on one side of the equation. The left hand side of the equation, keep your first term and the second term, which is the term with x squared and the term with x. After that, you divide by that a. Whatever that a was, you divide the entire equation. You divide both sides by the a. So what would you get? When I divide that, I'm going to write it down. Okay, divide by 4 on both sides. Both sides of the equation, that is. Okay, so divide by 4 on both sides of the equation. When you do that, you should get 4x squared over 4 plus 2x over 4 is equal to 5 over 4. Can you all see this? Okay, now this will be simplified as what? Okay, this 4 and 4 will cancel. This 2, that goes 2. And 5 by 4, leave it like that, even if it's an improper fraction, okay? So this would then become x squared plus 1 over 2 times x is equal to 5 by 4. Now this equation looks very much like the example number 1, where a was equal to 1. The coefficient of x squared was 1. Now it looks just like that. So now I would say go ahead and identify your b. Okay, now when you identify your b, that middle term, the coefficient of middle term, now the b is 1 by 2. Had you identified it earlier, then you'll have to talk about a new b. So that's why I said hold off to identifying b, because you have to work with b. Remember, you're finding a b by 2 and a b by 2 the whole square. So it would have been slightly confusing if you had identified directly right at the start, okay? Because then, yeah, it would be confusing if you know what I mean, right? So after you've done the first two steps, the first step being, isolate the c term, bring it on one side of the equation, and then you divide by a on both sides of the equation. After that, you identify your b, and your b would be 1 by 2. The thing to do after that is make it b by 2, okay? Find the half of it. Be careful here. So if b is half, half divided by 2 would be 1 by 4, okay? And then you find the square of b by 2, okay? So you find b over 2, the whole square. And so that can be written as 1 over 4, the whole square. Even if you don't evaluate it here, I mean, the last example, I know I added 4, which was b by 2 the whole square. I added that 4. Even if you did not simplify it, I mean, that was a simple number. That's why I wrote it that way. But if you are dealing with fractions, I'd say just leave it like that. This is still a simple fraction. Just leave it like that because it will help you identify what goes into the bracket. So we're going to add 1 by 4 the whole square, that is b by 2 the whole square, to both sides of the equation. I'm going to write it down. Add 1 by 4 the whole square to both sides. Okay, to both sides of the equation, that is. So when you do that, you're going to get x squared plus a 1 over 2x plus a 1 by 4 the whole square. Look, I've written it just like that, 1 by 4 the whole square. And there's a reason you'll find out soon. Is equal to 5 over 4 plus 1 by 4 the whole square. Okay. If you write it like this, it becomes easier to identify what goes into the bracket. And remember, our sign of b, the sign of the second term, the middle term, is plus. So you're going to get x plus. If the sign of the middle term was going to be negative, you're going to write x minus. Okay. Now it becomes easier to identify what that term is going to be. So that's going to be 1 by 4. That's why I said keep it like that. So this is going to be a square plus 2ab plus b square. That becomes a plus b the whole square. So key things to identify is that the sign of the middle term is what this is going to take here. And if you leave it like that, it will be easier to identify what this is. Otherwise, when you're dealing with fractions, that can be a little tricky. Okay. So that's the secret, keeping it as 1 by 4 the whole square. On the right hand side, you can simplify it as 5 by 4 plus 1 over 16, which can be further simplified as 5 4 is 20 plus 1 over 16, and that would make it 21 over a 16 on the right hand side. And on the left hand side, you still have x plus 1 by 4 the whole square. Now it's just a matter of taking the square root on both sides. So when you take the square root on both sides, you should get x plus 1 by 4 is equal to the plus or minus square root of 21 over a 16. All right. Now, if you had a square number, it would have been easier for the numerator, but the denominator is a square number. So you can write this as plus or minus under root 21 over 4. Right. That's x plus 1 by 4. So finally, you will get x is equal to a negative 1 by 4 plus or minus under root of 21 over 4. Those are the two values of x, the two roots, the two solutions of this quadratic equation when we solve it using the method of completing the square. Let's go with this method again, okay? So this was the case when a is not equal to 1. As I said, the first thing to do is isolate that c, all right? Bring it on one side of the equation, okay? It doesn't go, but anyway, whichever way you understand it, okay? Adding or subtracting both sides by the constant term, you'll isolate the constant term. In this case, it was c. It was a negative c, so you added c, negative 5 on both sides, and you got 5 on one side of the equation. Then, this is the important thing, okay? Divide by a. Divide by a on both sides. Don't identify a, b, and c right away, okay? Don't identify the b right away. So, divide by the a on both sides. In this case, it was 4. So, you divided by 4 on both sides. And then you'd get the middle term as 1 over 2. That is the b. That's the b that you're working with, okay? So, you half it first, just like we did in the first example. b over 2, and then do b over 2 the whole square. My suggestion is leave it as that 1 over 4 the whole square. Whenever you have a fraction, it becomes easier, okay? So leave it as 1 over 4 the whole square. That's the term that you're going to add on both sides of the equation. 1 over 4 the whole square on both sides. If you leave it like that, it becomes easier just to put that into this bracket. And remember, it's a sign of the middle term that will go here. If it was negative, it should be x minus 1 by 4 the whole square. 1 by 4 the whole square. So you have x plus 1 by 4 the whole square. On the right hand side, you simplify the two fractions. In this case, we have to find the LCM. And then you combine the two terms, and then it's just about finding the square root and then solving for x. So that is how you solve the quadratic equation by completing the square. I hope this video was useful. I'm going to see you all in the next video.